Hello, hi, namaskara. My name is Kirtan and welcome to my channel Physiology at Once. Today I'll be talking about the topic jaundice. This is one of the important topics in the GIT system and can be asked as a 5 marks question in the examination. So what is jaundice? Jaundice is the excess accumulation of bilirubin which causes yellow discoloration of sclera, skin and mucous membrane. So this occurs in order. So the first yellow discoloration happens in the sclera, then in the skin and then in the mucous membrane. The discoloration happens in the sclera due to the attachments of this excess bilirubin with the elastin compound. So this elastin which is present in the sclera attaches with the bilirubin and causes yellow discoloration. So first of all, what is this bilirubin? Bilirubin is a byproduct of the hemolysis product. So before talking about the jaundice deeply, first let's see what happens in the hemolysis process. So let's talk about the process of hemolysis. As you all know that RBC lives for 120 days and then afterwards it gets destroyed and it's converted into hemoglobin molecules. So this hemoglobin again converts into heme and globin. So globin is the protein part and it goes to the protein stores in the body. Whereas this heme contains iron. So this iron is taken up by the iron stores. So some of the heme is also reduced to biliverdin. So this division of the heme to the biliverdin is caused by heme oxygenase enzyme. And this heme to iron is caused by microsomal oxygenase system. I hope it's visible. So this biliverdin is again reduced to bilirubin, which is the main important factor in the jaundice. It is caused by biliverdin reductase. So these enzymes are very important for you to remember. Biliverdin reductase, heme oxygenase and this microsomal oxygenase system. So what happens to this bilirubin? This bilirubin is a lipophilic molecule. Lipophilic molecule. It means that it cannot freely float in the bloodstream. So that's why it needs to attach to a protein. So this bilirubin attaches to albumin. As you all know that albumin is a transport protein produced by the liver. So this bilirubin and albumin form a complex and this albumin carries the bilirubin in the form of a complex to the hepatic cells, that is the hepatocytes or the liver cells. So now let's talk about what happens to the bilirubin in the liver. So after entering the liver, the bilirubin detaches from the albumin and gets into the hepatocytes. So there are 3 steps in the bilirubin metabolism. So the 3 steps which undergo in the hepatic cells are, first one is the uptake. So the bilirubin is uptake by the hepatocytes, and after the uptake of the bilirubin in the hepatocytes, it gets attached with a protein called ligandin or ligandin. So ligandin plus bilirubin. So it occurs so that bilirubin doesn't escape back into the bloodstream out of the liver. So this complex is very big and cannot escape out of the hepatic cells. The second one is the conjugation step. In the hepatic cells and that too in the endoplasmic reticulum, the bilirubin is conjugated. So bilirubin is converted to bilirubin dichlorokinase with the help of glucuronide transferase. So you will learn more about this process in the biochemistry chapter. So after the conjugation part, there is the excretion part. This excretion part is the rate limiting step in the bilirubin metabolism. It is the rate limiting step. The bilirubin is excreted in the bile. Bilirubin is excreted with the bile, and it is an active process. So what happens to the bilirubin when it is excreted with the bile? So let's talk about that also. When the bilirubin is excreted with the bile from the hepatic cells, it goes to the intestine, and in the intestine it is again converted to the conjugated bilirubin. This is the conjugated bilirubin. It is converted to stercobilinogen. This stercobilinogen is again converted to stercobilin. This stercobilin is the main component which gives color to the stools. This gives brown color to the stools. So this conversion of stercobilinogen from the conjugated bilirubin happens due to the bacterial flora present in the intestine. So some of the stercobilinogen converts into urinary urobilinogen and is excreted through the renal system. Not all the stercobilinogen is converted into stercobilin. Some of the stercobilinogen is reuptake or reabsorbed from the intestine and goes through the enterohepatic circulation again. Enterohepatic circulation means that the intestine to the liver and then again to the intestine. So some of it is reabsorbed and goes to the enterohepatic system. So normally the bilirubin levels in the blood is 0.2 to 0.8 mg per dl. 0.2 to 0.8 mg per dl. Above this, that is excess or more than 2 mg per dl, causes jaundice. So this is the jaundice. Excess or more than 2 mg per dl of bilirubin in the blood causes jaundice. So this is how jaundice is caused. So there is 3 types of jaundice. The 3 types of jaundice are hemolytic, hepatic and obstructive jaundice. The main physiological causes of jaundice are increased bilirubin production, decreased excretion of bilirubin. So you can see that whenever there is increased bilirubin production, the bilirubin concentration will increase as per the bilirubin production. And when there is decreased excretion of bilirubin, then also there will be excess accumulation of bilirubin in the blood. So in the increased bilirubin production, there will be excess of hemolysis or increased hemolysis. So due to which more number of bilirubin is produced. So this excess of bilirubin hemolysis is caused in the hemolytic jaundice. So hemolytic jaundice, there is increased bilirubin production. In the decreased excretion of the bilirubin, the hemolysis will be normal, but there will be ineffective conjugation of the bilirubin that is caused by hepatic jaundice, or there is obstruction of the bile that is due to the obstructive jaundice. This hepatic jaundice is seen in the viral hepatitis, whereas this obstructive jaundice is seen in the biliary stasis. Biliary stasis means nothing but the obstruction of the bile duct, or the intrahepatic stasis, that is the obstruction within the hepatic cells. So let's differentiate these 3 types of jaundice and know about their features more detailedly. So hemolytic, hepatic and obstructive. So bilirubinemia. What is bilirubinemia? Bilirubinemia means that there is excess of bilirubin in the bloodstream. So in the hemolytic disease, there will be bilirubin, but it will be conjugated. So it will not be excess of bilirubin in the bloodstream. So this will be mild. In the hepatic jaundice, there will be excess of unconjugated bilirubin due to ineffective conjugation of the bilirubin in the hepatic cells. So there is moderate bilirubinemia. And in the obstructive jaundice, there will be severe bilirubinemia, because this bilirubin is not at all excreted in the bile and it converts and goes into the bloodstream. So there will be excess of bilirubin in the blood. Fecal stercobilinogen. So stercobilinogen will be increased in hemolytic jaundice. As we discussed here, that stercobilinogen is increased when there is increased conjugated bilirubin. So hence in this hemolytic jaundice there will be increased conjugated bilirubin, therefore there will be increased stercobilinogen. Whereas in the hepatic jaundice there will not be less conjugated bilirubin. There will be conjugated bilirubin, it will be in less quantity. So therefore it will be mild or decreased. Whereas in the obstructive jaundice there will be absence of fecal stercobilinogen, because the bile will not even cross the bile duct. So therefore there will be absence of fecal stercobilinogen in obstructive jaundice. In the urinary urobilinogen, it will be increased in the hemolytic jaundice. So it is the same process as the fecal stercobilinogen. If the fecal stercobilinogen is increased, the urinary urobilinogen will also be increased. And the same goes to the hepatic and obstructive jaundice. It will be mild or decreased, and it will be absent in the obstructive jaundice. So urinary bilirubin. So urinary bilirubin is caused due to the excess of unconjugated bilirubin in the bloodstream. So here there will be not much unconjugated bilirubin. So there will be conjugated bilirubin, excess of conjugated bilirubin, but the unconjugated bilirubin will be less. So this urinary bilirubin will be mild in hemolytic jaundice or also absent in most of the cases. But in the hepatic jaundice there will be presence of urinary bilirubin, because not all bilirubin is conjugated in the hepatic cells due to the ineffective liver function. So therefore some amount of bilirubin will go to the bloodstream freely unconjugated and can turn up in the urinary bilirubin. It is also same in the obstructive jaundice. So Van de Berg test. In this Van de Berg test, it confirms whether the bilirubin is conjugated or not conjugated. So in the hemolytic jaundice, most of the bilirubin will be conjugated. So it is an indirect test. And in the hepatic jaundice, some will be conjugated and some will be unconjugated. So therefore it's biphasic test. And in the obstructive jaundice, it is the direct test. The liver function will be good in the hemolytic jaundice. So it will be normal, but it will be ineffective in the hepatic jaundice, and also sometimes it may be ineffective in obstructive jaundice in case of intrahepatic stasis. So these are the three types of jaundice and its differentiation points. This table is most important and can be asked in the exam with the jaundice definition. So in this video we discussed what is jaundice and how it is caused due to the bilirubin excess, the bilirubin metabolism, the process of hemolysis we talked about the types of jaundice and what are the causes of the jaundice, its increased bilirubin production and decreased excretion of bilirubin. So I hope you understood this video. If you like this video, please like, share and comment, and also don't forget to subscribe. Thank you guys.